Hey, Addie. All right, so we're going to go over just a handful of problems off the motion worksheet. 100%. Copy this down. Use it in your homework. I'm trying to do some of your homework for right now, given that I gave you a ridiculous amount this week. I'm sorry, it doesn't usually end up that way. This week just is what it is because of how things come together. So we are going to talk about these equations. Before we get too far into these equations, I'm going to remind you of where we ended yesterday. We finished talking about these equations, and these are them. Now, over on the right side were those equations that we made. Now, before you get too much further, every year this happens to somebody. Please pay attention very close and make sure that you wrote these equations down exactly. I can't tell you how many times I've had a student go, I have been getting every problem wrong, but apparently this equation has a delta x at the end of it and not a delta t, and Spainauer's handwriting is crap and I couldn't tell that. So we're going to go through it real quick just to make sure, because this happens every time. You'll notice that the way I position them, I'll go in different orders, but there are two that start with delta x and two that start with VF, which kind of helps you memorize, which brings me to this. Spainauer, do I have to memorize the kinematic equations? The answer is no and yes. No, officially you don't have to. I'm not going to make you go and just memorize them. That being said, sort of yes, because if you don't accidentally memorize these with use over the time of this chapter, I will be surprised. It's not required of you at all, but I think you will, just because you'll look these up so many times that eventually you'll be like, okay, I think I have it at this point. Things that are missed the most often for whatever reason, at the end of this second equation, this t is squared. And as I already mentioned, at the end of the bottom equation right down here, at the very end is delta x, displacement. That is not delta t. So just running through them real quick, displacement is equal to velocity initial plus, that's another one, there's usually a minus that some people put there, plus VF divided by 2. That entire quantity is multiplied by delta t. The next equation, displacement is equal to velocity initial times the time interval, plus 1/2 times acceleration times time interval squared. Third one there, velocity final is equal to velocity initial plus acceleration times time interval. And the last one, velocity final squared is equal to velocity initial squared plus 2a delta x, or displacement. You'll notice I have a giant line running down the middle. I've just been talking over here on the right side. Okay, remember what I talked about at the beginning of yesterday. When do you use those? Over there on the right side. We said this towards the beginning of yesterday. When do you use those equations on the right? Think of the assumption I gave you at the very beginning. When the acceleration is always constant. Okay, in this class, it's a constant, period. But what is true of this right there? What is true of acceleration that we're using these? It's something other than zero. Correct. There is an acceleration. Okay, is a way to put it. Okay. When do you use this guy over here?
When acceleration is
zero. Correct, which means the velocity is constant. That's the other thing that you could say. If we use this equation, this is the constant velocity equation over here on the left side. You'll notice that the constant velocity equation is made out of 3 variables. I've already told you that by the way, these are regularly referred to as the kinematic equations, and sometimes I will accidentally slip up and say, hey, what are the kinematic equations? And I usually am referring to these 4, but technically all 5 of them are equations that describe motion or kinematic equations. Those over there on the right side, that when we have an acceleration, I mentioned this already, but just to review, how many variables make up each of them? 4. There are a total of 5 kinematic variables, which means that on all of those equations, one of the 5 is missing. Let's see if we can't spot them real quick. What is the missing variable of the first one? Acceleration. Correct. Second one? Velocity final. Excellent, Keiser. Let's get somebody else's voice in the room here. Somebody else? What is? That would be delta x, correct, displacement. And then finally, this guy at the bottom, time. That'll probably come into play here in just a little bit. But another couple quick reviews. Where did this kinematic equation come from? The third one. We talked about this yesterday. Where did it come from? Definition of acceleration. Thank you very much. And where did this first kinematic equation come from? of, put another word in the middle there, average velocity, yes. Small but important difference. All right, so like I said, what we're going to do is we're just going to kind of work through some of these problems. So Sean is traveling in her sweet Model T at a top speed of 40 miles per hour. She's a great driver. How long will it take for her to travel 30 meters? How do I start this problem? Well, for starters, as you see this gigantic divide between them, what's probably the first thing that you should try to figure out? No, before that.
Which side?
How do you decide which side?
Acceleration is constant.
Is there an acceleration? They're all constant, okay?
Right.
This is a constant 0, that's a constant something else, but yes, is there an acceleration or not? So, one big trick to this problem is some people are like, I don't like math problems that are word problems. I have bad news for you then, because every single physics problem is a word problem as we are trying to take math and connect it to the real world. One of the important things that you need to do when doing one of these problems is kind of have a picture in your head of what's going on. Use your imagination. Picture a sweet Model T. To help you with that, draw a picture. Nailing it right there. Boom. Sweet Model T. There we are. Great. That's not a Model T. With your picture, I've already told you that there's one very important thing, and you'll see why today that we have to do, and that's to establish a 0 and a positive. Most people who don't write this still assume it. They assume that the way that they're going is positive, and they started from 0. That's okay, but trust me, again, I think you will see this today, why that establishing is important. The second thing that's kind of important, and it'll seem dumb to begin with, is establishing what displacement you're talking about. Now, in your picture, that's just simple as, hey, let's draw an arrow and say displacement up here. The reason why that's important is drawing that picture, I know we're not dealing with acceleration yet, but if I put all 5 of those variables up real quick, all 5 of those variables are represented in that delta x. The velocity initial is the velocity when you're right there. The velocity final is the velocity when it's right there. The acceleration is the acceleration the entire time. The delta t is how long it takes to get from right there to right there. Hey, by the way, this isn't even up here, but what is this guy right here? That's your initial position and your time initial as well, and they're all up here. Simply by drawing a dumb delta x, that'll become ridiculously important. Oops. What happened? Boo. There we go. All right. So now we do our given. You probably want to have the problems out because I'm going to be flipping back and forth. So you're not going to be able to read the problems the entire time. So maybe get on Google Classroom to read them. Somebody tell me what is one. Oh, also make sure you have your calculators out. You'll notice I don't have a calculator. I attempt to do calculations in my head, but they're not going to be that perfect. What's given?
The top speed is 40 miles per hour.
Would you say, based on the reading of this, that she's accelerating or not? I would say no too. Doesn't say anything about her changing, slowing down, speeding up. Just says, hey, traveling at top speed. So we're going to write down velocity is 40 miles an hour. What else is given to us?
It'll be like 30 minutes.
What's that?
That's going to take her like 30 minutes. I didn't remember.
Not 30 minutes.
It's how long she'll take to travel 30 meters.
So what's given there?
Your displacement.
And sort of, and you're not wrong. It is displacement, but it's not.
Your position.
What was given to you, no, you're right. What was given to you is technically a distance. The problem doesn't know displacement or not. Somebody telling you a thing like that doesn't make it displacement. What makes it displacement is doing this and simply writing down, okay, that means it's positive 30. Yes? And that means that is the displacement. That's what's given. That's all that's given. What are we trying to find? Which is? Delta t. Since it's not accelerating, we can use, we only got one option. Good, we'll use that guy. Now, I mentioned this before. If you want to start here instead, you certainly can. I don't care. I really don't care on this one. It's so simple that I know you can do the math in your head anyway. Who the heck cares? But here it is. Notice, given, find, equation. Do not plug numbers in yet. I got a couple things to address. Number one, why can't we just plug numbers in immediately?
Because then
not quite, not that. You got the right idea of something else. I just mean, why can't we just calculate right now, Anthony? Units aren't match. Units don't match at all. I mean, think of it like this. If I walk 2 meters across the front of the room at 2 miles an hour, does that mean it's going to take me an hour to get across the front of the room? No, if units don't match, you can't compare them. So we need to do a conversion. When it comes to conversions, Spain, do I show the work or not? Just yes, because I saw your quizzes, okay? And many of you are very smart. But the deal is, when you show more work, you make less mistakes. A bunch of you guys and we need to kind of talk to some of you guys about conversions because the work is all over the place. And some of you guys, I know some of you looked up how long a year was in time, because if you have in your head memorized that 1 year is 3,156,000 seconds, I have a few questions about your condition and how exactly you do what it is you do, robot. All right, so make sure that you're doing that work to show it. I don't know if I've given you guys this yet, but one conversion that's used I think I did. One conversion that's used all the time is 1 meter per second. Yeah, I did. Is 2.25 miles an hour. If you don't have that down, don't put this in your problem. Don't put this in your homework. If you don't have that written down somewhere in your notes where you readily get to it, like maybe even on that AP equation sheet, put that there. And here we go. 40 miles an hour. Miles an hour goes on bottom. 2.2. Come on, Debbie. 2.25. 1 meter per second goes up top. 40 divided by 2.25 is obviously less than 20. I'm putting it in the 18-ish camp. Calculate for me. I need like 2 or 3 answers. What's that? We'll go 17.8. Can I get a confirmation just to make sure we're good?
Yeah, that's what I
Cool.
copied.
17.8 it is. Now, when you do conversions like this, feel free to do them on the side, but a good technique, especially for my people that struggle with organization, is to do this. 1, don't do them anywhere around here. Don't put them in a random spot. Put them somewhere to the side, and then do this. Don't erase. Don't do conversions ahead of time either. Write down what's there, but just next to it, right next to it. It's 40 miles an hour, but it's also equal to 17.8 meters per second. This is easy, so let's just keep going. Algebra. Algebra's easy. I still want to see it. Here's the algebra I want to see. Done. I don't need you to show me dividing V on both sides. I assume that you are doing that and doing it in your head correctly. We'll talk about more complicated algebra later. But given, find, equation. Always start at the initial equation, the definitions. I do not want you starting here. Okay? You should always start here. With the one exception. If there's a problem that has multiple parts, okay, and that part is just, hey, how long did it take her to go 30 meters? How long did it take her to go 60 meters? How long did it take her to go 90 meters? If it's the same algebra in the same problem, do not redo the algebra. Just go ahead and use the same equation multiple times, and that's fine, okay? If it's a different problem, I do want to see the algebra potentially again. Here's the plug-in part. Delta T equals 30 meters divided by 17.8 meters per second, which should be under 1. Let's get 1 point. Oh.
1.7.
Can confirm, a few of you? Everybody should be calculating. I don't care who yells out, but everybody should be calculating.
7.69.
Yeah, so we'll go 1.69. That's fine. 1.7 is also completely fine. I have no problem with it. Questions, concerns? So you know that's easy. Cool. The main thing I'm highlighting right here, once again, as I said a second ago, is when it's easy, we work on methodology. We make sure that we're doing this stuff correctly. Because next part, still not too bad, but maybe a little bit more complicated. Shauna then takes off from rest in her sweet Model T. How long will it take her to travel 30 meters if she accelerates at 1.7 meters per second squared? Now, with your given and find, if you have parts, like we're going to see in number 8, that are exactly the same. It's just asking you something different. No reason to redo the given and find if it's the exact same given and find. You can do the given and find for a problem, not for each individual part, with the exception, like here, if they don't belong together at all, which they don't. Here, she was traveling at about 17.8 meters per second, and according to part B, she took off from rest, which means what? 0 at the very beginning. You'll also see towards the end here that she's accelerating, so that doesn't belong with the previous one, so we do need a new set. Now what I like on given and find here, Since I know what 4 or 5 variables are going to be, I just usually write this ahead of time. You don't have to do that. It's just kind of a suggestion, especially for people that struggle with it. And know if we're going to use those kinematic equations, we need to find 3 things in order to get the fourth. So, what do we know?
Her acceleration is 1.7 meters per second.
Small thing here too, as I'm doing this, I just realized it. For whatever reason, sometimes people put dashes on these, okay? Don't do that. Why is a dash a bad idea? To say that acceleration
Looks negative.
looks an awful lot like negative, and you're going to mess that up, so make sure you're taking the extra time to make sure that's an equal sign. Yeah, what else we got?
Velocity initial 0.
Correct, velocity initial is 0. And?
Displacement is still 30, right?
Positive 30, but yes. What are we trying to find? Sorry, you said time? My apologies. I'm zoning on me. There's 2 ways to figure out what equation to use. Ultimately, the first line of logic is probably the best, because it's the most mathematical and the best thing. What do we need? We need the 4 variables, the 3 that we know, and the 1 that we don't. But if you struggle early on, here is a technique that you can use. Which variable is missing or we don't care about? Velocity final. So you'll notice how I set this up. You can go, hey, the missing variable is velocity final, and therefore this is the one that has the 4 that I want. Hey, it's almost like he did it on purpose. So, you're going to use this one a lot early on. As a matter of fact, I think this is the equation we're going to use for like the next 3, because it's just used that often. But let's talk about the algebra really quick. Spanauer's made a lot of effort to be like, don't do the numbers, don't do the numbers, don't do the numbers, with one major exception. I don't want you to plug in numbers, unless it's a 0, because 0 cancels stuff out and makes things a lot simpler. So what do we have that's a 0? And then you don't want to rewrite it right now. So what you do, there's a simple technique that a lot of physicists use, a lot of mathematicians use with something like this. They go, okay, if velocity initial is 0, it doesn't matter what time is at all, right? Because it's going to be 0. So you take an arrow and draw it straight through the term 0, showing yourself, yes, it did used to be there, but I canceled it out to 0, and now it no longer is in the equation. And now, nicely, I can do the algebra with just 2 convenient terms. See if you can't do this algebra to solve for delta t on your own real quick. I'll give you about 30 seconds to a minute to get ahead of me, and then I'll show the work.
So for the math, can we just, when we're doing the math, can we just plug in those variables that cancel out and then put a line through them?
Correct, yes. So my rule is again, don't plug numbers in unless they're zeros. If they're zeros, okay, you show that. You show the, by the way, also, notice this. I always still want you to show the initial equation. I don't want you to just write delta x equals 1/2 a delta t squared. You are going to show that canceling.
We don't have to redraw the picture.
I would say no, because it's the same picture. I mean, if you wanted to, I'm not going to get mad at it, but yeah, I would say no. It's the exact same picture in both cases. I think tomorrow, will be the finally, if you've kind of been sitting there like, why is Maynard making us draw? This is stupid, this is stupid, this is stupid. Tomorrow, a couple of those problems I think will finally make you go, oh, okay. I don't think I would have solved this without the picture. All right, so I'm going to start with the 1/2. You could certainly divide by 1/2 on both sides, but quite frankly, that's icky. It's way cleaner to multiply 2 on both sides. So that guy cancels, and I have 2 delta x over there. Then I divide by a on both sides, and I square root both sides, and I'm done. Spanauer, is that the algebra that I can show? Yep, sure. No problem with that whatsoever.
Is it okay if we still show us plugging in the
One.
numbers?
What's that?
Like,
Well, I'm not done. We will still plug in the numbers. I don't want you to plug the numbers in early, but in our steps, Jafeeps, it's given, which we have here, here, and here in the picture. Find, right there, equation, algebra. The very next step is plug in. I require you to do it because you'll see again later today where the numbers need to be. So if you want to plug it into the side or just underneath here, I have 2 times positive 30 meters divided by 1.7 meters per second squared. Please note that everything that has units, Spanauer is putting units for. 2 times 30 is 60 divided by 1.7, roughly maybe a little more than 30. Square rooting of 36 is 6. I'm going to say it's around 6, maybe a little less, maybe a little more. What's that?
5.94.
Oh, so. This happened to somebody in first hour, by the way, and so I'm going to kind of use this to bounce off, even if it didn't happen to any of you. Somebody in first hour said, hey, the answer is 35. What they, of course, didn't do is they had forgotten to square root. So one thing that's really helpful at the end of a physics problem is take a very small moment of time and ask, does that make sense in the context? We have a car. The car is going 30 meters, okay? 30 meters is about, I don't know, about 3 of these, actually about 2 of these rooms, okay? Not that far in terms of a car. Does it make sense that the car would take 35 seconds to cover that distance or like 6 seconds? Taking that small step and getting used to taking that small step will prevent you so many math errors, it's not even funny, okay? You'll see another one a little bit later today. All right, finally, part C. I'm going to set it up. I'm not going to actually I'm going to finish, but I'm just going to do it real quick because it's super, super quick. But the only thing I'm going to point out here is now she's traveling at 10 meters per second and accelerates. How far will she make it in 6 seconds? We got a new set of variables here. This does not match. So here we are. Her velocity initial is 10 meters per second. She is still accelerating at 1.7 meters per second squared. And she's going for a time of 6 seconds. Come on. And it wants to know how far she goes. Again, it's asking a distance, but the only calculation that we can do in here is with displacement. You will notice once again velocity final is missing, and it is the exact same equation over again. Does anything cancel here? Do we have any zeros to cancel? No, but the great news is watch this, and this is 100% going to happen on your algebra step. Do we need to do any algebra at all? It happens. Sometimes algebra is not necessary if it's already solved for. So we just skip ahead to the plug-in part. This is 10 meters per second times 6 seconds. Make sure you're putting units. Plus 1/2 times 1.7 meters per second squared times, and the major thing missed probably here is the squared on that guy. 6 seconds squared. 2 or 3 of you calculate that real quick, and we'll move on to the last problem. Is this someone's Yeti? This is a very nice Yeti.
I think it was Lily's. That would make sense.
She'll be back. Is there something in it? I really want to see if it weevils. There's ice. That's all I got to worry about. Hold on. It doesn't weevil at all. That's dumb. I won't push it down and it just goes back up. Answer? 10 times 6 is 60. 36. That seems a little off. 36. Half of that is 18. 18 and a half. 30-ish. 90? 90.6 it is. And that's in meters because it's a displacement. By the way, if you ever didn't know that it was in meters, watch this. Seconds cancels with seconds. Seconds squared will cancel with seconds squared over there, so meters plus meters gives us meters. Unit analysis. Hey, how about that? It's a thing. All right. Next problem. St. Jackson and Pope Trenton IV dropped Spainower's laptop off of a building. Spainower glares at them menacingly. Is that menacing? Probably not. All right. I guess they're just curious to see what happens. The top of the building is 100 meters tall. That is a stupid tall building, by the way. That, well, in terms of St. Louis, I guess not in terms of like New York. It's like 30 floors tall. Okay, it's decent. All right. How much time will it take for the laptop to hit the ground, and what velocity is it going when it hits? All right. So setting it up. Building. The building is 100 meters tall. That's what it said. Now, one thing that you might kind of get into the weeds on this is you go, well, Spainower, the building's 100 meters tall, but technically, you know, Trenton or Jackson do have a height to the laptop itself. Yeah, that distance is probably a moot point on this. It's not going to be that much. And if I give you something like this, I'm not trying to get into the weeds. If you want, you can imagine that they dropped the laptop from right here if it helps. All right, is the laptop going to accelerate? First thing you kind of need to address. Yeah, it is, which means we're dealing with that right half of the equations, and we're going to deal with 5 variables. And now another very important thing, and do not assume here, because you'll see where you're going to make mistakes. Where would you like your 0 and which way is positive?
Positive.
Okay, positive down, and your 0 at?
Zero.
Now I'm going to tell you right now, that is definitely the easiest way to do it. And if you did that on your homework, you'd be good. I'm going to do it in kind of the not easy way, but because it's going to come up, so why avoid the difficult thing in here if we can work through it. So let's go ahead and say up is positive, because quite a few of you probably would if you weren't paying attention. As a matter of fact, if you weren't doing this, what we're about to do like right now, you're gonna think that in your head. You're just gonna think up is positive. So that's what we're gonna do. Where would you like 0 to be? I don't care on this one though. There's 2 good options, I would argue. Ground is one good option. Technically, the other good option would be hands is also fine, but we'll go ahead and use the ground because that was said first. We're gonna say up is positive. What I'd like you and your group to do now, mostly you, but check with your group as well, is to go ahead and fill out the given here. The complicated thing in this problem is it only looks like there is one number given to you, and that's not true. There are 3 numbers given to you here. So if you can't find them, try to find them, discuss them with your group. We'll be right back after these messages.
Is this something that's due Monday?
Yeah. And just a heads up in case, so you don't redo it, I'm going to do number 9, the very next one, tomorrow. So, yeah.
I've run on a run to write number 8 down, and I'm already starting what I usually have to do.
Have any of you noticed that you're probably going to burn through multiple notebooks in this class? The record in here is 5. It's a 5 70-page notebooks.
I feel like keep using your notebook as like listed paper.
Don't do that either. We're going to use it, even if you didn't do that. All right. A lot of people also like a notebook for notes and then a separate notebook for homework. That's also really not a bad idea, so you don't accidentally use up that type of, but certainly up to you. All right, what do we got?
So the gravity
Is what?
9.8.
Now, when I do it in here, you remember I said that gravity is also seen as g. So I'm always going to write g, because g is 9.8 meters per second squared, because I'm lazy, okay? But it's not exactly g. It's g.
But I don't remember if it's velocity or if it's acceleration.
It's acceleration. It is acceleration of gravity. Meaning, if I dropped an object right now, here's why it makes sense that it's not velocity. If I drop this pen off of a building, is it going to stay at the same velocity? No. Is it going to stay at the same acceleration? Yes. And that's that 9.8 meters per second squared. All right, why is it not 9.8 meters per second squared exactly?
Gravity's funky.
No. It's 9.8. It's just not 9.8.
Thanks for that.
Come on, guys. Which way is gravity point, people? If you don't do that, what are you about to say just happened? Cool, but not helpful. And again, this is where that equal sign really matters. Now, to the point that Rihanna originally said, make down positive, would it be positive then? Yeah, and again, that does make things a little bit easier. And on your homework, feel free to make them as easy as you want. Just know what I'm pushing right now does happen, so you kind of need to be able to do it even if it's not the easiest thing. All right, what else you got? Yes, Aiden. 100%. We said dropped. The word dropped is your key thing there. Absolutely. It's 0. We have one other number. I mean, you guys knocked out the 2 that aren't given to you. Joe. Oh, careful there, Joe. I like that. Still not quite right. Okay, so I want to address that because that is a mistake people will make. You will get used to start calling gravity negative, which, by the way, this is a very important distinction, and we'll talk about this a ton throughout. G is not negative. you made it negative, or I made it negative, by assigning up as positive, which is why it's negative g and not just g, and we don't put the negative somewhere inside of it. Okay, but let's say you make this mistake. First thing, imagine what you just said. Imagine it right now. What you just said happened. You said you walked up the side of the building, you dropped it, accelerating was pulling it down, and what did the object do? Wait. Okay, now the great news about that is this. You're going to see in just a second that the math is going to scream at you if you do this the right way. Now, we want to find out how much time it takes to hit the ground. Great news is I don't need to spend a lot of time on this because we just did this exact same algebra a second ago. Now, while we did the exact same algebra a second ago, again, it's a new problem. We are still going to show it. Velocity initial is 0, boom, boom, multiply both sides by 2, divide by a, square root both sides, and we get delta t.
Are you going to change the 100 meters to negative?
Oh, yes.
Okay.
I'm going to talk about it when it is positive, so yes, it is negative. This is another reason, by the way, why it's really helpful to put positives even though you don't need to. Because it kind of, as a person, reminds you, if you don't have anything up in front, that you probably should be addressing that in some way, shape, or form. But let's put the numbers in. Now, watch carefully. I know you guys are copying me down. I appreciate that. I am going to have the video up so you can get this later, but watch this. 2 times negative 100 meters divided by negative g square root. I'll tell you right now, because I know it from last hour, the answer is 4.5 seconds. Now, watch this. Let's say you had made a mistake. Let's say you called g negative, but you accidentally did what Joe kind of did immediately. It was just a small mistake, and you said positive 100. It happens. Why is that going to tell you that that's not okay? Your calculator is going to scream at you that you can't have a negative underneath the square root, and you can't. So when that happens, you have two choices, one that's good and one that's bad. The good one is, if that happens, usually the mistake is somewhere over here in your given, although it can sometimes be algebra as well. You go back and you try to mistake it. Here's what I don't want to see, people, that happens all the time. They go, oh, that negative's a problem. Magic math. Now there's no negative in it anymore, and I'm good. If I see magic math on a page, I mark the crap out of magic math more than anything. You lose way more points sometimes in the don't magic math. It's way better for you to even write something on the side like, don't know where I went wrong, I'm getting a negative under. That is way better for you than magic mathing. Okay, but negative, negative, obviously your negatives, as they should, cancel. By the way, notice that if we had established down as positive, then that would be positive, and that would be positive, and positive, positive would, in fact, end up with the exact same right answer. Okay, lastly here, now it's asking you to find velocity final, or specifically the velocity it hits the ground. Two things on that front. Number one, that's not 0. Obviously, it hits the ground. Eventually, it will be 0. But colliding with the ground is its own acceleration. Okay? We are just looking at the acceleration of gravity. So velocity final is the final velocity when gravity was happening. Or that, if this is the ground, that instantaneous moment right before it collides with the ground. That's when it's asking. So it definitely is moving at that time. Yes? Also, another big thing to clue you in there, if you write a 0 here and a 0 here, that should set off things, because if it's accelerating, that means velocity is changing. And obviously 0 to 0 doesn't change, and that's a problem. Okay? So, next.
So are we finding the velocity final?
Correct.
So
You,
the one without.
well, hold on a second. You technically have 3 different options here. You can use any of them. It doesn't matter. Honestly, once again, if we go for the easy method, I would suggest this third equation, because I'll do it real quick. Boom, don't do that though, because we're not going to. This is 0, that's negative 9.8, multiplied by 4.5, and you should get a little bit closer to like negative 45, a little bit lower than negative 45. But I want to use this one because I want to show you something again in the math, okay?
Is it because there's no delta t, and that's the one that we don't want?
No, actually we do have delta t, because we just found it.
We found it.
Yeah, so we technically have, oh, I'm sorry, I'm in the wrong spot here. We technically have 4 variables right now. By the way, if you want to then fill 4.5 in over here, you can. I don't require it. I certainly don't require it. You have the answer over here. But, so you can technically use whatever equation has VF in it. I want to use this one. Nope. You use whatever works. And that's what I don't know if I said this the other day with kinematic equations. Here's the deal, guys. You might go one route with this, somebody else might go an entirely different route, and both of you should end with the exact right answer. These equations perfectly meld with one another. If you use two equations and somebody else has used two different equations, they better end up right or one of you did something wrong. So we still should get the exact same answer as if we'd used any others. Starters, VI is 0. Boom. Plug in zeros early. Next, algebra is super simple here. What's the only algebra I need to do? Square root. I will finish here tomorrow, but I'll tell you it real quick what the issue is. Oops. 2 times negative g times negative 100 meters ends up in your calculator as positive 44.5. I think that's what it is, meters per second. Should it be positive when it hits the ground? No. We do not magic math, so you can't make a negative appear, but there is math precedence here. Where is the negative actually coming from? What goes in front of a square root answer always? Plus or minus. You just use the minus because it's going down.